Good morning. In this video lesson, we're going to continue to work on solving equations. That's what we've been working on this entire week. Because the objectives and key terms are largely the same, I'm going to ask you to kind of pause the video, review those objectives and key terms like you were supposed to on your own. Now that you're coming back, we're going to go take a look at the guided problems. Problem number 1 today has an equation 4x plus 5 minus 6x equals 11 plus x. They ask us first to figure out how many terms are there, or how many terms there are in the green equation. And then when we see that many terms, what's a good first step to solve equations that have this many terms? After you answer part 1 on your own, go ahead, work out, solve the equation for x, answer part 2 as well. And if you get to an answer part 3, go ahead and confirm your answer. Or as Mr. Neville would have said last year, plug and chug is what we mean by substituting to confirm our solution. So go ahead, pause the video. I'm going to switch over to my whiteboard. As you're coming back from pausing the video, hopefully you worked this problem out. You have an equation, an answer to the equation, you plugged it in, and you actually saw that your answer is correct. But if you got stuck, if you want to see if your answer is correct, you're just not sure, we'll go ahead and work through this step by step. For part 1, how many terms are there in the green equation? The big thing we should see is that there are 5 terms in that equation. 4x, positive 5, negative 6x, 11, and positive x. 5 different terms. The big thing when we have that many terms is definitely going to be we need to simplify this equation by combining like terms. So again, there are 5 terms. Positive 4x, positive 5, negative 6x are all combined in the left expression, and that has to have the same value or be equal to positive 11 combined with positive x. Here I see 3 different variable terms. I'm going to put blue boxes around those. Positive 4x, negative 6x, and positive x. I also see 2 constant terms. Those are numbers without a variable. I'm going to put red circles around positive 5 in the left expression, positive 11, which is in the right expression. Anytime I see 5, 6 terms, I know there have to be some kind of like terms that have already been gathered. In this case, the 4x and the negative 6x are variable terms, like terms that sit on the same expression, the left side of the equation. So I can combine positive 4x with negative 6x. Hopefully you recognize that makes a negative 2x. I haven't changed anything else. I'm just simplifying this. Nothing in the right side of the equation is like terms, so they can't be simplified or combined. So the positive 5 will come down. Bring the equal sign, put that right on the river. And 11 and positive x are here. They can't be combined. They're not like terms. Now we've simplified to the point of having 4 terms, just 2 of them variable terms and 2 of them constant terms. Variable terms are not gathered yet, opposite sides of the equation. Constants are not gathered yet, so I'm going to use inverse operations to get those terms gathered. I could either move the negative 2x from the left side to the right side with a positive 2x, or I could have gone ahead and subtracted x to move this one over here. I prefer to add, so I chose to move all of the x terms, the variable terms, to the right side because it would have involved addition. But you could have gone ahead and done minus x and brought all the x's over to the left. That's okay if you did it that way too. X plus 2x would have given us 3x over here. The whole reason we added 2x was to eliminate the x terms on the left side. The positive 5 is going to come down. The equal sign comes down. So does the 11. I've now got 2 of the constant terms, and because the variable terms were gathered and combined to the right expression, I want the constant terms moved to the left. So I'm going to subtract 11, which is the inverse of a positive 11. That would eliminate the constant on the right side. But anything I do to one side of the equation, I'm required to do the same thing to the other. 5 minus 11 is going to be negative 6. That's equal to positive 3x. I've run out of room on my whiteboard. You could divide both sides by 3, but I know 2 times 3 is 6, which means negative 2 times 3 would be negative 6. So the last step I solved by inspection instead of using the inverse operation of division. X equals negative 2. If you got that same answer, double check my work. Please make sure you plug it in for each of the x's. Evaluate and see if it works in the equation. See if we get a true statement. At this point, I would encourage you to go ahead, pause this video or leave this video, end the guided problems, and move on to the practice problems for today. But if you want to get prepared for the toughest practice problems, problem 4, problem 5, there's an optional challenge problem in the guided problems. So again, you can feel free to pause this video, jump over to the practice problems. Give me 1 second there. Jump over to the practice problems and work on those. And right now, after you've paused the video, if you stayed with us, I'm going to go ahead, remove this whiteboard. And we're quickly going to run through how to solve this much more difficult equation that's got decimals, fractions, involves the distributive property, and has a bunch of like terms. So again, pause the video if you want to work this out. Otherwise, I would encourage you just to get going on the practice problems. All right, quickly, we should understand distribution is necessary. Anytime I see factored expressions and I want to solve these equations, I need to distribute to get into expanded form. The 0.5 times with 8y, that's the same thing as just doing half or dividing by 2. So half of 8y was going to be 4y. Half of 12 is 6, and a positive times a negative is a negative. Over here, I'm going to also distribute the 1/4. Multiplying by 1/4, timesing by 1 changes nothing, so I'm really just dividing each of these terms by 4. 32 divided by 4 is positive 8. Negative 8y divided by 4 is negative 2y. Equal sign comes down, positive 2 comes down. At this point, we should see 2 variable terms. They're not gathered yet. I can't combine them. 3 constant terms. 2 of those are gathered. So because they are gathered, I can combine negative 6 with positive 2 to negative 4. Rest of the equation comes down. Again, I like to add, so I'm going to move, instead of subtracting 4y, I chose to add 2y. I'm going to save some room on my whiteboards. The variables are coming to the left, so I'm going to move the constants to the right at the same time by adding 4 here. 8 plus 4 gives us 12. Over here we get 6y. 6 times 2 is going to give us 12. So it turns out here for this complicated equation, if you plug y equals 2 in to check my answer, hopefully I'm correct and you see y equals 2 is the correct answer. If not, go ahead and tell me I made a mistake and we'll figure out where it is. Thanks for watching. Good luck. And today we're going to play Kahoot at the end instead of doing an Illuminate exit ticket.